Hello, welcome to my channel. This is Mr. Campo, and today we are going to take a look at the real number system. In my course and most high school courses, high school math courses, you will use real numbers. Mm, Even in college, I think unless you go into advanced mathematics, you will not deal with imaginary numbers. So the real number system, we have different sets in the real number system. The first one is the natural numbers, which are counting numbers. And examples of these are uh, 0, 1, 2, 3, 4, up to infinity, right? And then the letter that we use for these is letter N, okay, for natural numbers. Next one is going to be integers. And for these, we use letter J or Z. And these are whole numbers, which are either positive or negative in zero. So examples of these are -3, -2. Well, I mean, these are just examples, but we can use -4, -5, -7, -1,000, -1, 0, 1, 2. I'm just keeping it simple. Next is going to be irrational numbers, for which we use the letter Q. Irrational. I'm sorry, rational. Did I say rational? And these can be represented as a ratio of two integers, P over Q. P and Q are integers. However, Q cannot equal 0 because division by 0 will give you undefined. What are some examples of rational numbers? Well, 1/2, 2/3, 3/4, any ratio of two integers, right? And if you represent them as decimals, they either terminate like this one or make a pattern, right? So this would be 1/3. This is 3/4. All right, and that's for rational numbers. Next, we have irrational numbers, and for these, I wrote the whole word, and the letter that we use for irrational numbers is I. Okay, and these have two categories. These have surds and transcendental numbers. I hope I spelled this right. Transcendental numbers. Surds is going to be square root of 2, square root of 3, square root of 7. Transcendental numbers, Euler's number, pi, and I guess these two. There are other, but I can't think of them right now. But these are transcendental. E, Euler's number, and pi, those are the most commonly used numbers in mathematics. If I remember the other ones, I will list them. Okay, and then let's look at our list. And all of these make up the real numbers system, real number set. And the real numbers are going to have both the rational and irrational numbers. Okay, so basically the real numbers are made up of these two subsets and their subsets. Okay, so rational numbers and irrational numbers, and then rational numbers, you're going to find integers, natural numbers, and for irrationals you have surds and transcendental numbers. All right, cool. Moving on, let's do some exercises so we can practice. State true or false for each statement. 2 over the square root of 3 is a rational number. Let's see. So we have 2 over the square root of 3 is a rational number. Is this true or false? So this is false, okay? And why is it false? You can do it, you can check it yourself. But if you divide a rational number by any rational number, you're going to get an irrational number, okay? So this becomes irrational. This is not rational. So this is false. Let me change the color just to mix it up. Red. I don't like that red. Green? No. Blue? Okay, let's try that blue. Or black. Oh, I like that black. Okay, let's see. 20 square root of 25 is a third. So that means that the square root of 25 is an irrational number. Is that true? That's false, right? This is the same as 5, and 5 is an integer, is a counting number, is basically a rational number, right? So this is not a third, this is 5, and 5 is a rational number. And why is it a rational number? Well, because you can write it as 5 over 1, right? And this is a ratio of two integers, and this is 5. Very simple, right? All integers are rational numbers. What do you guys think? All integers, all integers are rational. And that's true, because any integer, whether it's a negative integer, like -7, this can be written as -7 over 1, right? And this is a ratio of two integers, and that makes this a rational number. So all integers are rational numbers. You can think of any integer, any whole number, any whole negative or positive number, and if you write it as the ratio of two integers, it becomes a rational number. Even 0, right? We can write 0 as 0 over 1, and this is 0, right? Okay. Square root of -25 is a real number. Is that true? Square root of -25, it's a real number. This is false, right? False. This is an imaginary number. This becomes 5i, right? So I just show you how to simplify this real quick. So you can do it as 25 times -1, and then this becomes square root of 25 times the square root of -1, and this is 5, and the square root of -1 is I. Okay. What about I squared? What do you guys think I squared is? So it'll be the same as this, right? So this becomes -1, right? Because I equals the square root of -1. So I squared is -1. Okay, but that's not part of this course, especially not of this lecture. So let's just move on. Okay, 3 is in the set. Let's do this real quick. 3 is in the set of integers. This is J's for integers, J or Z, right? That's true. All real numbers are rational. That's false because you got rational and irrational, right? This one, it takes, but again, this is for my classes, so I should do all of them. Give an example of a number which is rational, negative, and not an integer. Okay, rational, negative, and not an integer. So let's see, what about rational, negative, and not, I like to use Z because that's what I'm used to, not an integer. So rational, we have to be able to write it, right, as a ratio of two numbers. Negative, okay, so let's start with that negative. Not an integer, so it has to be, it has to have a decimal, right? So -1/2 is one example, right? This is the same as -0.5. Obviously, that's not an integer. It's rational, is negative, and not an integer, right? So that's one example, -1/2. Real but not rational. So irrational, right? So it could be the square root of 2. Change the color. I want to make it like this. Real, but not rational. So we have, for the real numbers, we got rational and irrational. So if it's not rational, it's going to be irrational, right? So we have these surds or transcendental numbers, right? And lastly, an integer but not a natural number. An integer but not a natural number. So integer but not a natural number. So natural numbers go from 0 up to infinity, right? So if it's an integer but not a natural number, from -1 all the way down, right? So I don't know, -3 could be one example, -2, -7. Irrational but not absurd. So a transcendental number. So remember I gave you E and pi. Okay. All right. Let's move on. This section is very easy. Exercise 3 is very easy. All you have to do is indicate to which of these sets the following numbers belong. So 8, you write the letters for which the sets for which 8 belongs to. So let's just do it real quick. If I have number 8, this is a natural number. This is an integer, right? This is a rational number. What else? And is, so natural, integer, rational, and real, right? Do we have any other options? Natural, irrational is not irrational. Okay, yeah, so that's it. So, come on. Yeah, you can do these. And if you have any questions, you can ask me in the comment section. You can drop the question in the comment section. Okay. What I really want to focus on is this part right here, exercise 4. Okay. So let's see, we're going to change these fractions to decimal form and these decimals to fraction form. So how do we do this? Let's see. Example 4. We have this fraction 0.4 to a fraction. So this means that the number 4 repeats infinitely. So this is how you're going to do this. Different methods. You can use your calculator to find the answer. But if you want to do it by hand, you can also let x be this number here. And our goal is going to be to get rid of that repeating part, okay? So we're going to have to move that decimal point and then subtract the two numbers, the two new numbers, so we can get rid of that repeating part. Now, if I move the decimal point one place, let's see, I multiply it by 10. So this comes here, and this 4 is here, right? So now I've sort of isolated my repeating part. And that's what I want to do. I want to isolate it so I can go ahead and subtract it and get rid of it. And then I can write this as a fraction. So I'm going to subtract these numbers. 10x minus 1x is 9x. And this 4 point, and then the repeating part minus this repeating part, we just get 4, right? Because these two parts will cancel each other out, and we're just left with 4. I'm subtracting, let me do it on the side. I'm subtracting 0.4 with a repeating part from 4.4. I hope I didn't confuse you. So if I subtract, I'm basically subtracting this part right here. So I'm left with 4.0, right? And then this is multiplying the x, so I can divide by 9. And I'll get x equals to 4/9. So I'm just saying that, you see, that 4/9 is the same as 0.4 with that repeating 4. Okay? Let's do another example real quick. We have the number 0.163, and these three numbers are repeating. Again, you want to isolate this part and get rid of it. So I'm gonna let this be X, okay? Now to isolate it, I'm gonna have to move 3 places, the decimal point 3 places, right? So I need to multiply by 1,000. And if I do that, I move it 3 places and I get 163 point, 163. Okay, 163. Okay, so I just moved it 3 places, right? I multiplied by 1,000 and I was able to move the decimal point and isolate that repeating part. Now I'm going to subtract this from this so I can get rid of that repeating part. So if I subtract this from this is 1x, 1000x minus 1x, 999x, right? And if I subtract this from this, I'll just get 163.00, right? I'm writing these 2 zeros, but it's unnecessary. I'm sorry, these 3 zeros. Well, it's 2 or 3. These zeros have no effect on the number, right? After the decimal point. And now I'm multiplying by 999, so I'm going to divide by that. And my number is going to become 163 divided by 999. Oh, x equals to 0.136. Okay, so first I'm going to make 2 new numbers. I'm going to multiply by 10. And I'm going to move at 1 place, the decimal point, and I get this. Now I want to isolate this repeating part, and I'm going to multiply this by 100, right? Well, no, by 1,000. The original one by 1,000, right? To move it 3 places. So it's going to be 136 times 36. Okay, and I'm going to combine these two now. I'm going to subtract this from this. So 10x minus 1,000x, 990x, right? And then this 136.36 minus 1.36. The repeating part is going to cancel out. And then 136 minus 1 is 135. Now I'm going to divide by 990. So 135 divided by 990. Simplifies to 3/22, okay? All right, that's gonna be it for today. In the next section, we're gonna do ordering of real numbers, okay? And some terms in mathematics, all right? So thank you very much for watching, and I hope to see you in part 2.